Hello guys, Samuel here. In this video, we are going to be solving the algorithm problem product of array except self. This is a common problem in technical interviews and it doubles as a good brain teaser also. So let's dive right in. Given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in big O of n time and without using the division operation. There are several ways to solve this problem. And to see these different solutions, first I would like to ignore the two constraints in the problem. The first constraint is the fact that the algorithm should run in big O of n time, and the second constraint is the fact that the division operation should not be used. Now let's dive into see these implementations. I would like to define two terms, order products and current elements. The order product of an element is the product of all the other elements in the array except that element, while the current element is the element whose order product we are trying to calculate. So given an array 1, 2, 3, 4, what the algorithm wants us to do is to calculate the order product for each one of these elements. So for the first element, I'll calculate the order product, and that is 2 times 3 times 4, which is 24. For the second element, the order product is 1 times 3 times 4, which is 12. For the third element, the order product is 1 times 2 times 4, which gives 8. And for the last element, the order product is 1 times 2 times 3, which is 6. So this is the array the question wants us to return. For the first solution, for each element in the array, which I'll call the current element, I'll go through all the elements in the array so as to calculate the order product for that current element. I'll make use of a variable I to keep track of the position of the current element, and I'll make use of another variable j to iterate over all the elements in the array. Then I'll create another variable product to keep track of the order product for each current element, and I'll initialize this to be 1. So for the first element in the array, since the current element is not supposed to be included in the product, I and j are pointing to the same element, I'll ignore the current element. So I'll move j to the next element in the array, which is 2. Now I'll include 2 to the product. Next, I'll move j to the next element in the array, which is 3, and I'll include 3 in the product. Next, I'll move j to the next element in the array, which is 4, and I'll include that in the product also. So now I'll calculate this product. This is 1 times 2 times 3 times 4, which is 24. And I'll include that in an array. So once I'm done with this current element, which is 1, I'll move to the next current element, which is 2. But before I do that, I'll reset the product back to 1 and then move j back to the first element in the array. And now I move I to the second element in the array, which is 2. Now, since I and j are not pointing to the same element, so I'll include this value of j, which is 1, to the product. And now I move j to the next element in the array. But since they are pointing to the same elements, I'm not going to include 2, since 2 is the current element. It should not be included in the other product. So I'll move j to the next element in the array, which is 3. Now I include 3 in the product. And finally, I'll move j to the last element in the array, which is 4. So I include 4 in the product. Now 1 times 1 times 3 times 4 gives 12. So I'll include 12 in the array. Next, I'll go ahead to reset the value of the product to 1. And then I'll move j back to the first element in the array. And now I move I to the next element in the array, which is 3. Now I include 1 in the product. I'll move j to the next element in the array, which is 2. I'll include 2 in the product. Now I'll move j to the next element in the array, which is 3. Now I'm not going to include 3 in the product because it is a current element. I and j are pointing to the same element. And now I move j to the last element in the array, which is 4. So I include 4 in the product. And this gives 1 times 1 times 2 times 4, which is 8. Now I'll reset the product back to 1. I'll move j to the first element in the array, and then I'll move I to the last element in the array, which is 4. Now I include the value of j in the product. The element j is pointing to, I'll include that in the product, which is 1. Then I'll move j to the next element in the array, which is 2. I'll include this in the product. I'll move j to the next element in the array, 3. Then I'll include 3 in the product. Now I'll move j to the next element in the array, which is 4. But since I and j are pointing to the same element and the current element is not supposed to be included in the product, I'll ignore it. So now this product is 1 times 1 times 2 times 3, which is 6. Now, and this is the same thing as the result the question is expecting for us to return. Now, the time complexity for this algorithm is big O of n squared. And that is because for each current element, I am going through every element in the array. And that gives a time complexity of big O of n squared. Now, since the question asks us to return an algorithm of big O of n, I'll not be implementing this solution in code. Now, for the second solution, what I'll do is that I'll calculate the product of all the elements in the array. And for each element in the array, I'll divide the product by that element. So the product of all the elements in the array is 1 times 2 times 3 times 4, which is 24. Now, for each element in the array, I'll calculate the other product. And for me to calculate the other product, all I have to do is to divide the product by the current element. So 24 divided by 1 gives 24. 24 divided by 2 gives 12. 24 divided by 3 gives 8. Then 24 divided by 4 gives 6. And this is the same as the array we are expecting as a result. Now, the time complexity of this algorithm is big O of n because I'm going through all the elements in the array just once. But then the question told us not to make use of the division operation, so I will not be implementing this algorithm in code. But for the first and the second solution, you can find the code in the GitHub link in the description. Now, for the last solution, taking element 2 as an example, to calculate the order product for 2, I can multiply the product of all the elements to the left of 2, which is 1, by the product of all the elements to the right of 2, which is 3 times 4, and that gives 12. For the next element in the array, which is 3, the product of all the elements to the left of 3 is 1 times 2, which is 2. And the product of all the elements to the right of 3 is 4. And this gives 8, which is the order product for element 3. So I'll keep track of two arrays, a left product array and a right product array. So for each current element, the left product array will keep track of the product of all the elements to the left of it, while the right product array will keep track of the product of all the elements to the right of it. So let's populate the left product array first. Starting from the first element, 1. 1 has no element to the left of it. So the left product for element 1 is 1. Now for the next element 2, to calculate the order product for 2, instead of iterating over all the elements before it, I can make use of the value we had earlier calculated. So to calculate the left product for 2, it is the left product of 1 times 1, and that gives 1. Now I'll be moving to the next element, which is 3. The left product of 3 is the left product of 2 times 2. So that is 1 times 2, which gives 2. Now the final element, which is 4. The left product of 4 is the left product of 3 times 3. Now the left product of 3 is 2. Then times 3 gives 6. So I'm done calculating the left product for each element in the array. Now I'll go ahead to calculate the right product. To calculate the right product, I'll be starting from the last element in the array. This is because I don't want to iterate over all the elements after a particular element to calculate its right product. I want to make use of a value that had been earlier computed to calculate the right product for any current element. Starting from the last element in the array, which is 4, there is no element to the right of 4. So the right product of 4 is 1. Now I'll go to the next element before it, which is 3. Now the right product for 3 is the right product of 4 times 4. The right product of 4 is 1 times 4 gives 4. Now I'll go to the next element before 3, which is 2. The right product for 2 is the right product of 3 times 3. So the right product of 3 is 4. 4 times 3 gives 12. Now I'll go back to the first element in the array, which is 1. The right product of 1 is the right product of 2 times 2. The right product of 2 is 12. 12 times 2 gives 24. Now I'll create another array called products, and the element of this product array would be the product of each element in the left product array times the corresponding element in the right product array. So for the first element of product array, it will be 1 times 24, which is 24. The second element will be 1 times 12, which is 12. The next element is 2 times 4, which is 8. And the last element is 6 times 1, which is 6. And this is identical to the array we are supposed to return. Now, I would like to talk about the time and space complexity of this algorithm. The time complexity of this algorithm is big O of n. Now, why is it big O of n? To populate the left product array, I have to go through each element in the array once. So if you have n elements in the array, that will take n operations. So that is big O of n time complexity. Now to populate the right product array, I have to do the same thing, go through each element in the array once. And this gives big O of n time complexity too. And to populate the product array, I have to go through each element in the right product and the left product array once. So that takes big O of n time complexity also. So I have big O of n plus big O of n plus big O of n. That gives big O of 3n time complexity. And in big O notations, the coefficient is usually ignored. So this approximates to big O of n. The space complexity of this algorithm is big O of n. Why is it big O of n? For the left product array, it will require big O of n space. And this is because if you have an input array of n elements, you would require a left product array of n elements also. The same thing applies to the right product array. It will require an array of big O of n space. For the product array, an array of big O of n space is also required. So big O of n plus big O of n plus big O of n gives big O of 3n. And just like I explained earlier, this approximates to big O of n. Now I'll go ahead to implement this solution in code. The first thing I want to do is to get the length of the input array. I'll save that in a variable called len. Next, I'll create the left product array. The length of this array will be the same thing as the length of the input array. Now I'll create the right product array. To have the same length as the input array. Now I'll go ahead to calculate values for the left product array starting from the first element in the input array. Since the first element in the input array has no elements before it, I'll set the left product for that element to be 1. Now I'll compute other values for the left product array starting from the second element in the input array. The left product of an element is the left product of the element before it times the element before it. Now I'll go ahead to compute values for the right product array starting from the last element in the input array. Since the last element in the input array has no elements after it, I'll set the right product for that element to be 1. The last element is at index len -1. Now I'll go ahead to compute the right product for the other elements in the input array starting from the second to the last element. The second to the last element is at index len -2. The right product of an element is the right product of the element after it times the element after it. Next, I'll go ahead to create the product array to have the same length as the input array. To populate the product array, for each element in the left product array, I'll multiply it by the corresponding element in the right product array. Now I'll return the product array. Now I'll go ahead to run the code for correctness. It has passed. I'll submit. It has passed also. I already talked about the time and space complexity of the algorithm. The time complexity of the algorithm is big O of n, and the space complexity is big O of n also. That's it for this video. Thank you for watching. If you found this video to be helpful, kindly hit the like button. To get more content like this on programming education, subscribe to my channel. I'll see you guys in the next one. Happy coding.